Alright, welcome to Earth Science, everybody. Here we go. It's time to figure out how to use this thing right here, which just doesn't work on the computer screen. So remote students got mailed these, hybrid students got handed these, and I told everybody to bring them home. If you're here in the classroom, go right up to the front corner of my desk. There's going to be a pile of these and some thin pieces of scrap paper here. If you're at home, you're going to need to find something that's a piece of scrap. You can use a whole piece of paper. We only need the edge. You know, an envelope, a piece of scrap, whatever it takes, or a whole sheet. All right. The premise is that we've got to figure out how far away an earthquake is based on the time gap between the P wave and the S wave. Conceptually, it's exactly the same as what you do when you see lightning and then hear thunder. You might count 1 Mississippi, 2 Mississippi. We'll point outside. There's no lightning and thunder today. It's nice and blue. But if there was a storm out there and you saw the flash, you would count 1 Mississippi, 2 Mississippi, 3 Mississippi until you hear the thunder, and then you estimate about how far away it is. Same deal here. Only it's with the slower P wave, primary wave, and you should have just learned about those in the notes. I'm sorry, the faster. My bad. The faster primary wave and the slower secondary wave. So our job will be to take a difference in time. Here's a sneak preview of what this will look like. This is going to be your practice sheets, where I'll help you through at the bottom, and then your lab is going to look really exactly the same. So it'll say, here's the arrival of a P wave at this time, here's the arrival of the S wave at this time. Can you figure out, given that the P wave arrived at this time, that's listed, S wave arrived at this time, that's listed, can you take the difference in those two times and use it to figure out how far away the distance of the epicenter is? And then two other things that we'll get to. So let's do it step at a time. So I'm making up one right here just to make our math simple. Let's say the P wave arrived here at Pulaski High School at 12 o'clock. If we had the detection equipment, we don't. And the S wave arrived at 12:04. That makes our math nice and easy. How far apart time-wise are those two? All right, they are 4 minutes. So our job really is, can we figure out where these two lines are exactly 4 minutes apart? So, you know, it might be tempting to say, okay, I guess we got to like count, and these are minutes over here. So 1 minute, 2 minutes, 3 minutes, a little bit more than 3 minutes, but that's not 4. That's the concept. Only the counting thing, like guess and count, would take forever. It'd be really frustrating. So here's what we do. We take the spare piece of paper. All right. I'm going to be very specific here, and I'm doing this to help you. I'm promising this is the easiest way to do it. I'm not going to take you through the hardest way to do it. This is the easiest way. Take your piece of paper and line it up on this y-axis, which is travel time in minutes. Now, I'm doing a couple things here deliberately. I'm leaving some paper down here at the bottom. That's recommended. I am leaving one box worth of space over here so that I can see these little increments, which we might as well mention what they are. If each of these is a minute, that means each one of these little lines in between is basically like a third of a minute, which is like complicated, right? Until you say, well, actually, that's just if we do that in seconds, it's pretty easy. So that's 14 minutes, 20 seconds, 14 minutes, 40 seconds, 15 minutes. Okay, so yeah, let's do that. Note that I didn't put it right on the edge, because then you can't see those little boxes. Note that I didn't put it on this side, because then you can't see the numbers, and you're, like, totally in trouble. Put it right like that. I'm promising this is the easiest way. Be careful. Line it right up. Be extra cautious. I'm trying to do this with my left hand while holding a camera. Kind of awkward. All right. Now that we did that, well, all we've got to do is figure out what is 4 minutes on this piece of paper. So I'm going to mark this right here and say that's 0. And then, sorry. I know this isn't ideal doing this with this video camera. I wish we were just all hanging out and doing this in person. But we're not. Keep it up, folks. You're doing great. All right, so what I did, I marked off the 0 and the 4. I was very careful to do it, even though I'm holding this video camera. And now I know that that amount of space right there is 4 minutes. Right? I mean, test it. What if I put this on 10? Well, then that's on 14. So it's 4 minutes. That piece of paper is going to let me cheat and slide around until I manage to find exactly where there's a 4-minute gap in between here. So like, here's an example of doing it wrong. There, that looks good. But that doesn't, that missed, so that's not right. I'll do it wrong again up here. That looks good, but that misses, so that's not right. Where can we find that one spot, only one exists, where we're right on? Let me switch to my right hand here. So I'm thinking it's right about here. Now, the reason why I left extra paper hanging underneath the bottom here now becomes obvious. It might have seemed a little abstract when I was here. You say, why do I do that? Just trust me, because I'm trying to get you the easiest way to do this. That's why. So now I've got the 4 right on the line, on the S line, the 0 right on the P line. That's the spot where there's 4 minutes in between them. And if I come down to the bottom, it's marked right there. I just marked it. You don't have to mark it. But I sent home 2 so that you can write on these things and make them a little messy if you need to. Okay, so it's on that line, but the other thing we got to think of, and I already did this because I got halfway through this video and then there was a lockdown drill here at school. Perfect timing. These distances are in times 10 to the 3rd kilometers, which basically just means thousands. 2,000s, 3,000s, meaning each one of these boxes then is 200. So at that line right there, I'd say 2,000, 2,200, 2,400, 2,600. So if these are 4 minutes apart, that earthquake must have been 2,600 kilometers away. All right. Again, same thing you do with thunder and lightning. You take the slower wave and the faster wave, you get the difference in time, and you use that to estimate a distance. We're doing that much more precisely because we have this graph to help us out. Okay? So I think there's a couple other things we got to do. I'll do those as separate videos though, so that when you're going to get lost a couple times doing this. This is not like intuitive or easy. It takes watching these videos a couple times. It takes practicing. What that video showed us was, given these 2 times and the difference between them, how do we get a distance? All right, sound good, folks? A couple other things to figure out, but we'll do that on another video. Excellent work so far. We'll see you in a minute.